I always feel bad because I feel like my face is never on there because I'm always the one screen sharing.
Yeah.
Okay.
You know what? We can do something else.
Let's see.
For a pidgey. I was gonna do homework. Grade papers.
Quizzes.
So maybe my teacher would respond and tell me if my rubric that I made for him is like, did we work okay? So we did great, but he hasn't even back yet.
That's annoying.
Mm-hmm.
So is it an online class or is it like?
Mm-mm. I can go talk to him, but he's out of town.
Okay.
So I have to wait for him.
We completed.
So it's like so once again,
Kind of.
grading any of those things.
I
But
thought I had the right answers. Okay.
It's not right then.
Whatever. You can fix it.
Okay.
Yeah.
Here's a link to the non-public applet.
Yeah.
Okay. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample is 25. So let me write this down. I found out that it worked better if I write it down.
Oh.
I've never been able to talk for me.
Just feel like
Yes.
Okay.
In freshman year of high school, so there's like a tournament.
So
As like us on the cheer
to
team,
find the margin of error, that is the. I totally wrote down the wrong thing because I was looking at the wrong.
that was
That's frustrating.
Okay.
Okay.
We all got out in the first round. It was
Oh.
so fun.
that was funny. You and Haley both.
Maybe I didn't write down the wrong thing.
Yeah.
No, that looks right. Yeah.
Because I wrote down this. Oh, you can't see my finger. I always forget that. But I wrote down this one. But that's not the error.
No.
Weren't you?
Yeah, like I was a competitive cheerleader for
Oh,
like
cool.
12 years.
Oh wow.
Yeah, so I made it till which is pretty high. It was
Yeah.
like level 5, but I made it to level 4, so
That's good.
super cool.
That's awesome.
Margin of error.
I really wanted to do
So it's
college cheer.
Mm-hmm.
M
I
equals
realized how expensive tuition was.
Z.
Oh yeah, that's crazy.
Do we know what Z is? Or are we trying to find Z? Or is Z the 90%? Is Z 0.90?
Yeah. We have to plug that into the applet.
Oh. What?
The 90%, we put the 0.9 as the area, and then it gives you the Z.
Oh, I totally wrote that down. So for 0.9, the Z is 1.645.
Yeah.
Oh yeah.
That was on the paper.
It's been a long time now.
Yeah.
So it's positive, right? We use a positive one.
Guys that were really good.
6.4.
Oh.
I'm like,
So it's
for a cheerleader, I'm one of the bigger
and
ones
then
to look at.
times.
And so if you're not
Yeah, because it's over. What did she say? Over 25 or over
That would be
50 or something?
Mm-hmm.
How did we know if it was positive or negative?
Yeah, that's great.
Oh,
You know,
yeah.
like
If it's under 50,
Yes.
then
You
it's
did.
negative. If it's over 50, it's positive. And that's one of the questions I got wrong. I was so mad. So, like, you know how you have the standard deviation on the 68, 95, 99.7 rule?
Mm-hmm.
And
And
I,
we didn't
the
like
question
wear
was like,
clothes
oh,
together.
yeah, this number. And it was one standard deviation to the left and one standard deviation to the
Yeah.
right. And I counted that as 2. So I put 95% instead of 68%.
Oh.
Those
Yeah,
equals
I'm
1 standard deviation.
Yeah, you were thinking like 2 standard. Yeah. Oh man.
2. And I just like got it mixed up in my mind, and I was
Oh.
still little mistakes like that is why I did the way I did.
Yeah.
I'm gonna go
Nothing happened.
in with my calculator.
Okay.
Like the first date, he told me he was like,
I'm just gonna take you with me.
Okay.
You're totally fine. Don't worry about it. We like never get to be in the living room ever, so like it's kind of nice to be out there.
Yeah.
One of our roommates has a boyfriend. They're always
Oh.
in the living room.
funny.
24/7. So it's like whenever I can be out there, I'm out there.
Enjoy it, right? It makes you enjoy.
Yes. Okay, so we do 50 divided by the square root of 25, which is 10,
Mm-hmm.
times 1.645 equals 16.45. So is that the margin of error?
Yes.
It's just 16.45?
That's what I'm thinking.
Okay. Which of the following statements is true? Ouch.
Oh my gosh.
I hate questions like this.
Mm-hmm.
So
Oh my gosh. I have no idea what they're saying.
so why don't we do this? I might do point estimated. Oh, there we go. Point estimators.
Oh.
How do you know? How do you know?
Okay, it says the statistics above are called point estimators because they are just one number that is used to estimate a parameter. Parameters generally unknown values. Think about the mean. If u is unknown, how do we know if x is close to it? Because up there on the chart that you had,
Right here.
yeah, because the first one is on there. X is a point estimator of u. That's one of them.
That is one of them. So,
but it also has it backwards. The third one has it backwards. So, but what we're reading is X, right?
Yeah. I think it'd be the second one then, if anything.
Yeah.
Yeah. Oh my gosh, I totally was looking. Oh my goodness. I can't believe I was looking at the wrong thing for like 30 minutes.
Trying to figure out why are my answers not matching?
Yes.
Yeah.
Oh
my gosh. That's frustrating.
Okay, Gina wants to construct a 95% confidence level. She knows the standard deviation. She clicks a simple random sample size of 64 and computes. So, what is the point estimate for the true GMAT score?
Awesome. Is it 526?
Yes. Yeah? I don't know.
Yeah, I think it is. Because I remember a similar question on the part 2.
Part 2. Yeah, I would have known if I wasn't looking at the wrong thing the whole time. Oh my goodness. Oh, wait, where happened to my preparation? I think I left my preparation out there. That's okay. What is the margin of error? Oh, okay, so the point estimate is just one number. Oh, okay, that makes sense. What is the margin of error for the 95%? So I brought that in here too. And 5 is 1.960.
But that's the Z.
Yeah, that's the
Then
Z.
we have to do what was it?
1.960 times 113 over the square root of 64.
Okay.
That times 1.960. I got, you have your answer?
No. Yeah.
27.685?
Yeah.
Cool. 27.685. 3 decimals is okay for that, right?
I think it said. Oh, yeah.
Oh, it doesn't say anything. What is the lower limit of this confidence interval?
So we have to do.
We have to do this. The minus.
I think it's the same thing. Because there's another one. Good. Oh, right there.
This
Oh,
one?
wait. Kidding. Just kidding. Just kidding. Where was it? Because it's just the x minus the m. Is that what it was? Which the m is z times standard deviation over sample size. Square root sample size. I think it's that.
This right here?
I think it is.
So then
Yeah,
we
'cause
would
it says
do,
affecting the confidence interval. Yeah. So, and it's asking.
sorry, keep going.
And it's asking for. What is? Oh wait, what was the question? Oh my gosh. Lower limit.
Oh, lower limit, yeah.
So we subtract then. We subtract the mean 526 minus the 27.685, right?
We do.
Because we just did z. I'm pointing at my screen like you can see it. Because we just did this z times standard deviation over square root of n, right?
Oh, yeah.
Yeah, so then we subtract the 526 since that's the mean, that's the x, minus it because it wants the lower one.
27. Yes. Ah! 26 minus 27. 685. 498.315.
Yes.
I was trying to figure out, I was like, wait, we just got our Z. Like our Z is 27, but that's not. Our Z is the margin.
Yeah.
So that makes sense. Okay. What is the upper limit? So 526 plus 27.685. 553.685. What would happen to the width of the confidence interval if Gina increased the sample size? It would increase, right? Like if we did,
I think it gets smaller.
oh yeah, it would lower it.
Mm-hmm.
Just did an example. So decrease it.
Yeah.
What would happen to the width of the confidence interval if Gina changed it to 99? So if we did times 2.6, that would increase it.
It would increase it?
Yeah, because I did the 99, the z-score, which is 2.576, times 113 over the square root of 64, and that equals 36.386. So if you plus and minus that, that would increase it.
Okay.
Does that make sense?
Yeah. I thought for the life of me that it would get smaller. Wait, what's it asking? What happened to the width of the
If you change the confidence interval.
I thought it would get smaller.
If you plug in the 99 like into the normal probability applet, it gives you 2.576 as your z-score. And so I just plugged that into our equation that we have, and it gave us a margin of 36. 27.
What? I thought I read somewhere. Oh my gosh. You may be right. Okay.
Are you thinking of this one, the sample size increases?
I don't know. For some reason, I thought they were both decreased. It's 2.576, right? So 2.5. Oh my gosh, 2.576 times.
Yeah, I would say it increases.
Oh my gosh. That makes sense. You're right. I don't know what I'm thinking. I don't know.
Don't worry. Oh my goodness.
49.614. I think I don't know. Okay. What would happen to the confidence interval if the confidence level were increased, say from 95 to 99%?
Are you asking me?
Oh no, that's what I'm reading on the actual thing. Prep under 4.2. Increasing the confidence level would lead to a larger value. If z is increased, then the margin of error would increase. Am I just reading the question wrong? I think I was just confused. I don't know. You're right.
Right?
I think so. Yeah, that's what it says, because it says if z is increased, then the margin of error would increase.
Yeah.
Yeah. Okay.
Okay. So 11. I was reading this one and I set up the equation while you were.
Okay.
So Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95 confidence interval with a margin of error of 50 hours. What is the sample size? So I did 50 equals 1.960 times 400 divided by square root of n. So we need to algebra this thing.
But 1.960 times 400, right? That's what you have on the top. And then you divide that by the 50.
Wait, what?
Because that's the margin of error.
Yes.
So then and then you square that, right?
What?
So we're looking for the sample size, right? Yeah. What sample size? So we do z, which is at 1.960 times 400 divided by 50.
Wait a second. I'm still using the other one. Were you not supposed to use the other one?
There's another one. That's
Well, no, you were using
but you're using the right formula. Wait.
Yeah, m equals z times sigma over
Okay.
n.
So after that one, they gave another one. That's a sample size formula. And so this one, it's n equals z times standard deviation over m squared. Well, everything squared, not just the m.
Z times sigma over, wait, what?
Over margin of error.
Divided by m.
Yeah. Divided by m.
Everything squared.
And then all of it squared, so it's all in the parentheses.
I'm still mad at looking at the wrong one. Okay. So then it would be n equals 1.960 times 400 divided by 50. All of that squared.
Yeah.
Oh my word. Okay. And how do I square this? Oh. 63.374? No?
That's not what I got.
Oh, times. Oh, I minused it. I subtracted it. Because that my dot looks like a minus sign. I got this. Give me 1 second. $245.862.
Yeah.
Got it.
And then you round up.
Yes. Wait, round up. Oh, it's the nearest whole number. So
Yeah,
246. Okay. The mean salary. Oh, I can't. I'm not sharing this with you, huh? Okay. The mean salary of actuaries is $100,000 and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but you are not sure if it is higher or lower. You set up a hypothesis test with level of significance of alpha equals 0.05, and those are your hypotheses. You collect a simple random sample of 36 women's salaries and find that that's the mean, right?
Yeah.
The sample mean is $111,000. What is the lower limit of this? Wow, that was a lot of information. Just ask that question.
Oh my gosh.
Okay, so lower limit. Okay, so first we need to find the margin of error, right? So that would be M equals 1.960 times sigma, which is 36,730, divided by 36, square root of 36, right? Okay. Did you get 11,998?
Yeah.
0.46. Okay. .467. Okay, now for the lower limit, we just do $111,000 minus the 11,000, right?
Yeah.
99,001. Round this to the nearest whole number, so 99,002. What is the upper limit? $12,290. Wait, 122,998. Yeah?
Yeah. Because it rounds down.
Yes, because it's only a 4. Okay. So let's see. Sorry, I'm writing this down. Lower limit, upper limit. Equals. Okay. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are all of the above. That was easy. Well, you ready?
Yeah.
Are you ready for this? Dun, dun, dun. Oh no! Oh, I saw a 0 and I was like, oh no! We got it wrong. Cool!
Oh yeah.
That scares me when it like has 0.05 or 0.5 points because I see a 0 and I'm like, crap, I got that wrong. What did I do wrong? All right. Well, cool. Do you have any other questions?
Nope. I'm set.
Alrighty. Well then, I'm thinking. Wednesday at 6.
Yes.
Okay, cool.
Okay. Sounds good.
Yep. If you have any questions on the like homework or anything, just text me,
All right.
and I will do the same to you because I guarantee I might have a question. Anyways, I'll post this.
Perfect. Thank you.
Have a good night.
Too.
Bye.
Bye.